All right, we have problems 10 through 13 now, and we are solving for x. Leave answers as simplified radicals if needed. We have right triangles, and they've given us two sides of the triangle, and we need the third side. Pythagorean theorem is going to help us out here. When we write Pythagorean theorem, make sure that the hypotenuse is on its own side of the equal sign. So I'll just go ahead and label that that one's the hypotenuse. This one's the hypotenuse. This one's the hypotenuse. And down here, they changed the orientation of the triangle, but this one is the hypotenuse. Okay, as I set up the equation over here, I'm going to say 5 to the second power plus x to the second power equals 10 to the second power. 5 to the second power is 25. 10 to the second power is 100. I can subtract 25 from both sides of the equation. I have x squared equals 75. To solve for x, I'm going to take the square root of both sides. So keep writing up here. X equals the square root of 75. Now often when we're solving here to say x squared equals something, and we take the square root of both sides, we will want both square roots, the positive and negative square root. In this case though, we're looking for a length or a distance, and those are always positive. So we're looking for just the what they call the principal square root. 75 is the same as 25 times 3. If I take the square root of 25, I get 5, and 3 is just left behind as 3. So to solve for x in this case with our simplified radical, we get 5 root 3. Let's try number 11. We're going to do 7 to the second power plus x to the second power equals 25 to the second power. 7 squared is 49. 25 squared, I gotta plug this into my calculator, I don't have it memorized, so I'm hitting 25, that button squared right there, and it's telling me that the answer is 625. Subtract 49 from both sides so that we isolate x squared. So now I'm taking 625, already got that, minus 49, 576. I'm going to see if 576 is a perfect square. So I'm just going to get second square root, second answer. And it is, it's 24. So 24 to the second power is 576. So that means that if I were to come up here, x equals 24. So this one must be a Pythagorean triple, right? All three numbers are whole numbers. 7, 24, and 25 fit this relationship. Okay, let's try number 12. So we will say 8 to the second power plus 10 to the second power equals x to the second power. The hypotenuse has to be on its own side of the equal sign. So 8 to the second power is 64. 10 to the second power is 100. 100 plus 64 is 164. I don't know if that is a perfect square, so I'm going to try it. Square root 164. Got 12 point stuff, so that's not it. So I'm going to factor this, divide it down if I can. I know that 164 divided by 4 is 41. 41, I think, is a prime number. Let's see, it's not divisible by 2 or 3 or 4 or 5 or 6 or 7. And that's enough. Those are the only ones we need to test. So, square root of 4 times 41, x is going to be 2 root 41. And I can test that out to see if I've done my correct arithmetic. So I'm going to take the square root of 164, and I got 12.80624.847. Then I'm going to take 2 square root of 41, and it is also 12.8. So I know that I simplified the radical correctly. Those two things are still equivalent to each other. Okay, we have one more. This one's going to be 7 to the second power plus x to the second power equals 9 to the second power. So 49 plus x squared equals 81. Subtract 49 from both sides. 81 minus 49 is 32. Running out of paper over here. So x equals the square root of 32. I know that 32 isn't a perfect square, so I'm going to divide this into pieces if I can. 32 is 16 times 2. The square root of 16 is 4, so I can get rid of that, and the square root of 2, I'll just have to leave that behind. So our answer is going to be 4 root 2.